Root cause analysis is one of the main steps in the DRBFM process, where after you identify your change point and the change matrix, and you already told which is your concern as a potential or as a confirmed concern, then you jump to the A rank sheet as we discussed last time, and the A rank sheet can be translated into causes following the root cause analysis. So what is the root cause analysis? It's basically tracing the problem from the symptoms all the way to the cause. As you can see here, if the symptom is bad fruit in the tree, then the root cause to the problem is all the way down by following all the causes that are making that tree giving you a kind of defective fruits. Those problems could be outer problems, so the root cause should be analyzed for the neighboring systems in this case, or it could be from the tree itself. So you want to go dig down into the roots. That's why they call it root cause analysis. You dig down to the roots and find all the causes behind that problem that you're experiencing, and that is done through a systematic analysis process in order to identify the root cause of the problem. So the root cause in simple steps is basically tracing the problem all the way to the source, described by the depth, where is the intervention or interaction can be implemented to prevent the outcome, which is known in the DRBFM as recurrence prevention. And the DRBFM application will help you finding the potential causes and considering the robust design. So in DRBFM, you are basically taking each part in terms of the part design and in terms of the part interaction with the neighboring parts and the neighboring systems and assemblies. And when you think there is a problem or a cause or symptoms to a problem, then you follow all the details in that part until you find the potential cause. And this way you will land into your robust design, or back to our example, you will have a healthy tree giving you useful fruits because you already removed all the causes from its roots and you already made sure the neighboring systems or the neighboring effects around it, like the environment, are doing a good cause to that problem. So root cause identification in the DRBFM worksheet. So that's an example of DRBFM worksheet, an A rank sheet in this case. As we said before, the A rank sheet, there is the root cause analysis sheet, which is known as the 5Y. So 5Y is the same as the root cause analysis. So you are saying why I'm experiencing this problem because of this, if you remember, and why I experienced that problem because of that, and so on until you reach your source. So in this case, we visualize the change point in our A rank, clarification of change, then you do the discovery of issues. So you discover all the issues that could show up or already showed up because of change. And here we derive the root causes for our problems. And eventually the resolution of issue or the solution of the issue, which is a systematic elimination of each issue by eliminating the cause of that problem. Either that problem in the part itself, in the dimensions, in the design, in the material, or the neighboring systems. If you think the neighboring system is harming your product, then you want to better make sure the product is away from that system, or if possible, eliminate that system from interacting with your part. So the root cause in the DRBFM, again, it's all about what, how, when, and where. So what is your problem statement and how do you address your root causes of your problems? So firstly, you want to study the failure phenomenon for the parts and for the components. When does that problem show up and where does it show up in that part? Is it in certain area? Is it in certain season, in certain time, and so on? Then you go to the causes behind that root problem that you have in your system. So you define how by asking why. So how does your system fail that way? When you tell how, then why does it fail that way? It failed because of problem A. And why do we have problem A? Because it's located in location B, and so on. Then you will talk about the possible conditions and circumstances behind that problem, then the different perspective and assumptions. Like in this case, the environment impact on the design and the manufacturing. Again, we already said the root cause analysis in DRBFM is looking something similar to this. If we take the example of a car, so the car is overheating. You remember that example? Why? Because the engine temperature increased. Why? Because we have a poor engine cooling. Why? Because the fans are not working. Why? The power supply cable is disconnected. So fans, power supply cable disconnected, making the fans off, making the radiator heat up, making the engine temperature increase, and after all, the car is stalled from overheating. So that's the way you go. And as we discussed before, you can go from down up by using the word therefore. So why the power supply is disconnected? So therefore, power supply is disconnected, therefore fans are not working. Fans are not working, therefore your poor engine cooling. There's a poor engine cooling, therefore the engine temperature increased.